Hello kids, welcome to Mammoth Online. So today I have a very interesting question from previous years, and here they are asking the number of elements in the set. So this is a question from set and relations. They have given that A intersection B intersection C is the required set they want, from which they want number of elements in that particular A intersection B intersection C. What is set A? They have given an expression like this one. We will learn what is this in detail now. B is also there, is given this way, and C is another set which is like this one. So we will investigate each one of them and find out how many solutions are actually there. So I would approach this using graph, which will be way easier to solve. So we have set A. So what they are trying to say is set A is such that they have elements like x comma y belonging to R and R, which means both elements x and y are coming from R and R. That is fine. And they also said that this particular set A has x and y relations such that it is mod of x plus mod of y is greater than or equal to 1. Now what is this? What does it mean? Let's figure out. Okay. So first we have to understand what is mod of x plus mod of y greater than or equal to 1. So now understand that there are 4 possible scenarios for this one. That is, there is a possibility that x and y both can be positive. Then in this case, we can remove the mod, because the goal is to remove this mod and make it simpler for everyone to understand. So mod of x plus mod of y is greater than or equal to 1. If they say this, let's remove the mod. So one case is we have x greater than 0 and y greater than 0. So we'll get x plus y greater than or equal to 1. What does it mean? To understand this, let's see the graph. Now understand that x plus y equal to 1. If we had a graph like x plus y equal to 1, this is a straight line. And here we can find what is a straight line by putting y equal to 0, we'll get x equal to 1. And similarly, if you put x equal to 0, then y will be equal to 1. So x equal to 1, y equal to 1, that is this line. So this line is saying x plus y is equal to 1. But here they are not saying equal to 1. As you can notice here, they are saying greater than or equal to 1. So this represents a region. What is that region? Let's figure out. So if you notice, this is where x is 1. Since we have 1 comma 0 here, x is 1. So if you put any number greater than 1 for y value, this will be somewhere over here. So let's say you put x equal to 1, y equal to 1. That will be somewhere over here. Now as you can see, this 1 comma 1 is a region where x is 1, y is 1. Now if you substitute that x equal to 1 here and y equal to 1, you will get 2. Which is definitely greater than 1. So it is satisfying this inequation we have here. So basically this represents all the parts of this particular line's upper region. So entire this pink region is represented by this inequation we have here. What is that? And that is simply x plus y greater than or equal to 1. That is a pink region above that line. And on the line it is equal to 1. So we have this region above the line and also the line itself because it is equal to 1 as well. So this is this entire region. Now we can stretch the line. Now similarly, you can figure out that this was done only for x greater than 0 and y greater than 0, which means we will have x greater than 0 over here and y greater than 0 for this particular part. So it's only between these regions we have this entire thing. So we cannot talk about any region which is x less than 0 and we cannot talk about any region which is y less than 0. So we will erase these parts because that is not the region we are talking about. Clearly it is x greater than 0, y greater than 0. So within this boundary of x and y axis, we have this pink region above that line. Now similarly, you can find x minus y greater than or equal to 1 when x is greater than 0 and y is less than 0. This is the second case. So what is this line? You can see that y is equal to minus 1 and x is equal to 1 kind of situation it is. So we can draw this line very easily. Now if you were to draw this line, you will see that x can be 1 and y should be equal to minus 1. So which means this line will go from here to here like this one. Because this is where we have y minus 1 and x is still 1. Now if you try to find what is the region here that we are interested in, so this was the pink region. Now we can figure out what is this region as well. Let's say this is the green region. And you will see if you substitute any value here, this region is where x is positive and y is negative. This is the only region we are talking about. Now similarly, we can also draw for the region x minus x plus y greater than or equal to 1, where x is less than 0 and y is definitely greater than 0. Now let's say we represent this region with some other color, let's say blue color. Now you will see that when x is 0, y is equal to 1, and when y is 0, x is equal to minus 1. So this is a line that is going through this particular part. So let's say this is a blue line. And this also represents the region. If you substitute some values, you will see that it's the upper region we are talking about. So this is the region we are interested in for this one. Similarly, we can talk about one more scenario, that is minus x minus y greater than or equal to 1 when both x is negative and y is negative. Now in this case, let's represent that with a white line, and that will be this line, and the region would be, let's say, this particular part. So as you can see, these are the different regions represented by this particular A. So this entire regions that is covered here, this represents set A. Now this way we can also figure out what is set B. Now if you notice here, the set B is talking about some situation like this one, where x and y belongs to R and R. So x is coming from R, y is coming from this R, both are real numbers. And the relation between x and y is something like x square plus y square less than or equal to 1. So what is this? So let's understand. Imagine we have a circle and the center is origin and the radius is 1. This kind of circle has an equation, that is x minus 0 whole square plus y minus 0 whole square is equal to 1 square. Distance from this origin to any point which is the locus of this particular circle will be equal to this equation. If you simplify, this equation is simply x square plus y square is equal to 1, which is the equation of a circle. So x square plus y square equal to 1 represents this equation of a circle. So let's say that equation of circle is this one. Now when you say x square plus y square less than or equal to 1, what does it mean? Now you take any point inside the circle, for example 0, 0, which is the center of the circle. If you put 0 square plus 0 square, which will be 0, which is definitely less than or equal to 1. So clearly we can understand that any point we have inside the circle represents this entire x square plus y square less than 1 scenario. So every point inside the circle and also all the points on the circle as well combinedly represents this particular B set, which represents x square plus y square less than or equal to 1. This region is represented by this particular diagram. This pink region and the red is combinedly representing this particular region. Now let's see what is set C. Now set C is saying that x and y belongs to same R and R such that maximum of mod x or mod y is equal to 1. So what does it mean by maximum of mod x or mod y equal to 1? Now imagine mod x is the maximum and it is equal to 1, which means definitely mod y was less than mod x because that is when it is the maximum. So if mod x is 1, x should be equal to plus or minus 1. Okay, so let's label that points. So x is either plus 1 somewhere here or minus 1 if that is the max. So let's say this is 1, 0 and this is minus 1, 0 when x is the maximum. If x is maximum, every y is minimum, correct? So if every y is minimum, where will that lie? So you can understand that mod x is the maximum. So mod y is actually lower than mod x, which means it will be between 0 and 1. So y should be between 0 and 1, that is mod y. So which means we know that y is 1 here and is minus 1 here. So y should be in between these regions. So definitely x is plus or minus 1. So if x is 1, as we can see, y will be anywhere between oscillating in this particular interval. So it can be here, it can be here, it can be here, it can be here, it can be anything in between. It is oscillating here. So it's like a straight line which is between minus 1 and 1 but not equal to minus 1 and 1. So at minus 1 and 1 it will be empty, but it will be equal to less than or equal to minus 1 and 1. Similarly over here it will not be equal to 1 and it will not be equal to minus 1, but it will be oscillating between them. This is when mod x is equal to 1, that is mod x is maximum. The other scenario is when mod y is maximum. That is, let's say maximum is mod y, and that should be equal to 1, which means mod x is definitely less than mod y. So mod y is 1 means y should be plus or minus 1, which means this particular part and this part. Now in this case, what will happen is x will not be equal to plus or minus 1 because mod will become greater, but it will oscillate between this region. So firmly speaking, the only region we have is basically this red lines, not touching at 1 and minus 1s, where this is all empty. This is our set C. So kids, those were the set. This was set A, and this was set B, and this was set C. So when you bring all these together, this is what we get. So first of all, these regions are our set A, this shaded region, and set B is basically this circle and the entire region that is encompassed within this circle and also the circle itself. This is set B, and set C is this white line we have basically, except those endpoints. So now, what is the intersection between A, B and C? That is, A intersection B intersection C is what we have to figure out from this diagram. So as you can notice here that this line is there. So clearly the region inside the circle is needed. So this region inside the circle, if you notice, is also part of our set B. So if you see this intersection, and also the point on the circle is also part of our thing, but if you notice, this region is only intersecting with set A this much, that's it. And with set A and set B is intersecting only these edges here like this one, but it is not interacting with set C at all, except the 4 points we have. If you notice very carefully, only 4 points are actually helping us to figure out all these things. So let's see what are those 4 points. So this white line and this region and this circle itself intersect at this point, that is our 1, 0, then at 0, 1, and then also at minus 1, 0, and also at 0, minus 1. These 4 points are the places where we are seeing that these regions, set A, set B, all are intersecting with each other. So the common elements, that is A intersection B intersection C, is actually 4 points we have, which is 1, 0, 0, 1, minus 1, 0, and 0, minus 1. So there are just 4 points. So there are only 4 points for this particular question. So let's see the options. So in the option, we can clearly see that so only 4 elements are there, which is going to solve this particular problem. So we will write 4. So this is how you solve this beautiful problem. In the next video, I'll see some more interesting questions like this one. Thank you.